1.6b. So we're sticking with absolute value, but now we're going to absolute value inequalities. So inequalities, again, is going to have a greater than symbol, less than or equal to, greater than or equal to. And we kind of do the same thing with solving them. We just have to remember our steps of if we multiply or divide by a negative, we got to flip it. But again, we got to set up two inequalities, okay? So the little difference is here, these end up being compound inequalities with an and or an or. So looking at the first example here, this says 2x minus 1, and the absolute value is less than 5. I have a little silly thing that I do, but this is a less than symbol, okay? Less than, and I spell it wrong on purpose because anytime you have the absolute value by itself and it's a less than symbol, then our answer will always be a compound inequality that is an and. And an and compound inequality looks like this on a number line, 5 and 8, and they would both be open dots, and it'd be everything in between. So that's what it looks like with an and, is when the answers are everything in between. Okay, so this is going to, it says less than, so automatically right before I even start, when I get the absolute value by itself, it's going to be an and inequality. So my solution should say x is greater than the smaller answer and x is larger or smaller than the smaller number. Okay, so absolute values by itself. There's two ways to do this. I'm going to show you both. Okay, 2x minus 1 is less than 5. So some of you may have had Mr. Kalkbrenner. I know that he teaches this when he does it is drop, flip, change. So we would go drop the absolute value, 2x minus 1. We flip the inequality symbol, so it becomes a greater than, and we change that to a negative 5. So again, drop, flip, change, and then we just solve these like we would any inequality, but you have to get two answers here. So again, I would add 1, 2x is less than 6, divide by 2, and x is less than 3. Here I would add 1, 2x is greater than negative 4, divide by 2, and x is greater than negative 4. So again, reading this on a number line, it would look like this. Here's negative 4. It's an open dot. Here's 3. It's an open dot. And it's everything in between because it's less than 3 and greater than 4. Okay. Interval notation, always left to right, just simply looks like this. Both in parentheses, almost like an ordered pair. Why is that both in parentheses? Because it's just the less than. Now, me personally, this is how I would solve this problem. 2x minus 1 is less than 5. Okay, I would take the same exact inequality symbol and put it over here and make it a negative 5. So you put the same inequality symbol as if I was picking it up off the paper and putting it here, and then you make the opposite of, and then now whatever you do in the middle, you have to do on the right and the left. So negative 4 is less than 2x. Oh boy, this is bad math right here. Sorry, that should be a negative 2. And that should be a negative 2. And that should be a negative 2. Okay. Sometimes we make mistakes. It happens. Is less than 6. So I would divide by 2 everything. So basically whatever you do in the middle, you do on the left and the right. Okay, and the reason I like this is, look, it's already in order here. Here I had to switch it and it wasn't in order. So again, if I were to graph this, it would go negative 2, 3, both open dots, everything in the middle. So I get the same answer. Okay, interval notation would go negative 2 to 3. Okay, make sure you look at this, your notes. That should be a 2, not a 4. I screwed that up. Okay, so that's any less than symbol. So again, we got to get the absolute value by itself. Once it's by itself, you can tell me whether it's an and or an or. Okay, so for this problem, 2x plus 4 is greater than or equal to. So again, little stupid play on words. Greater. Okay, which means it's going to be greater than. It's going to be smaller than the smallest number and larger than the largest number. So setting this equation up, and I'll do it both ways. 2x plus 4 is greater than or equal to 6. And 2x plus 4 drop, flip, so it's less than or equal to, opposite, negative 6, okay? So solve these, subtract 4, 2x is greater than or equal to 2, divide by 2, you get x is greater than or equal to 1. Here, subtract 4, 2x is less than or equal to negative 10, divide by 2. Notice I'm dividing by 2, so I'm not going to flip anything. x is less than or equal to a negative 5. So again, writing this out, make sure your number line is always in order. X is less than or equal to negative 5. X is greater than or equal to 1. Interval notation would be negative infinity to 5. The 5 has a bracket around it because it is included. Then we would start right back up here at 1 with a bracket around it, and it would end at positive infinity. Again, the way that I would set this up, 2x plus 4 is greater than or equal to 6. Again, you use the same symbol, so these will always point the same way. And then you just put the opposite of whatever the answer is over here. So whatever I do in the middle, I have to do on the right and the left. Be negative 10. It's greater than or equal to 2x. Is greater than or equal to 2. I divide all middle, right, and left by 2. Negative 5 is greater than or equal to x. Is greater than or equal to 1. So again, interval notation, negative infinity to negative 5. We always include negative 5 and never infinity because it's a greater than or equal to or symbol here. And then the little union symbol starts back up at 1 and goes to positive infinity with our interval notation. So a problem straight from Delta Math. So in this problem, it's a little bit difficult because we have to get the absolute value by itself. So I'm going to subtract 6 from both sides. 5, absolute value of x minus 5 is less than or equal to 5. Lots of 5s there. Divide by 5. Do never distribute in there. So now I have absolute value of x minus 5 is less than or equal to 1. So first of all, this is a less than. So I know this is going to be an and inequality. Okay, so I'd set up x minus 5 is less than or equal to 1. X minus 5 is less than or equal to negative 1. Check that. Not less than or equal to. Right? You got to flip it. So it would be x minus 5, don't change that sign, would be greater than or equal to a negative 1. And then we solve it, add 5. X is less than or equal to 6, add 5. X is greater than or equal to 4. So again, it would look like this in interval notation. X is greater than 4, so all the numbers to the right of 4. X is less than or equal to 6, less than, so it'd be everything to the left. It's everything in between those two. Again, I wouldn't solve it that way just because I like the way that it's set up. You don't set up your two inequalities until you have the absolute value by itself. If you do that too early, then one of your answers will always be wrong. So I would set this up this way. I got the absolute value by itself here. So I would set up x minus 5 is less than or equal to 1. Use that same symbol over here, and it's just a one-step problem. Plus 5, and you would get 4 is less than or equal to x is less than or equal to 6. And then look, they're always in order when you do it this way. So 4 to 6. That's how I prefer to do it. Okay, now there's a couple of different cases that could happen when you get the absolute value by itself, and unlike the equations, you have to read it, okay? So you have to think about this. Remember, with equations, if this was negative, we always said no solution. Well, with this, no matter what number I plug in here for x, it's inside the absolute value, so it would always be positive, right? And isn't a positive number always greater than or equal to negative 5? So because the symbol is greater than or equal to, or just greater than, then this would be infinite solutions. No matter what number I plug in here, it will always be greater than negative 5. Okay? And likewise, if I had x plus 3 is less than or equal to negative 5, again, this will always be positive, so that could never, ever be less than negative 5, so this one would be no solution. Okay? So there'll be potentially a couple problems like that. Just make sure that you're reading this. There's a difference between inequalities and equations when it comes to having a negative on the other side. And this kind of explains it. This is from the book. Kind of explains it. I'm not a huge fan of it, but again, this talks to the less than. Anytime you have the absolute value with a less than, or equal to, it's always going to give you this, which again, in interval notation looks like an ordered pair. Okay, so it's going to look like for a less than, it's going to be negative A to A, or in brackets, negative A to A. Okay. So again, it will always look like that. And then if you have a greater than symbol over here, it's going to be an or. It's always going to go all the way to the left. So an or always starts at negative infinity, goes to whatever my answer is. Okay. And then again, we use parentheses or brackets based on what symbol we have. Then it starts back up at my answer, and it always ends at positive infinity. So with an and, we'll never use infinities. With ors, we'll always use both negative and a positive. You'll have an assignment here with about probably 6 to 8 problems.